I'm waiting for more students to join the class. I will wait for another 2 minutes. Hello. Still only 36 participants. Okay, I think I must start the class right now. Today I'm going to solve few problems on conductors. Okay, this is going to be the last class of module 4. Uh, let me start the class right now. And try to follow the problems as much as you can. Okay, because if you don't understand the logic behind solving the problem, it is very difficult to understand. Okay, I hope you can see the problem, and don't bother of writing the questions. I will share these notes with you. Just try to observe the logic behind the solution. Okay. Now, I hope you can see this. Can you see the solved problems of module 5? It is actually module 4. Can you see this? Please raise your hand. If someone, I just want to make sure that this PDF is visible to all. Okay, Harshita, I am raised hand. Okay, thank you. Thank you, friends. Okay, let us start today's class. I will solve few problems and you just understand. And I will share this document with you guys right now. Just look at your WhatsApp. I'm going to share the notes with you for E section, right? For E section, okay. This is the solved problems on conductor. I hope you can see it right now. Okay. The first problem goes like this. The Fermi energy level in silver is 5.5 electron volt. I will highlight what are the important things. We have Fermi level of silver, which is 5.5 electron volt. We have to find the velocity of the conductor electron, of the conduction electrons in silver. Okay, we have to find the velocity, and if the relaxation time for the electron is 3.83 into 10 power minus 14 seconds, we have to calculate the mean free path. Okay, there are two quantities we have to find. First thing, we have to find the velocity of the electron, and also second thing, we have to find the mean free path, that is the path available for the electron between two successive collisions. Okay, these are the two things, and previously these questions are asked for 4 marks, 2 marks for finding out velocity and 2 marks for mean free path. Nowadays they are asking it for 3 marks. That means 1.5 marks for finding out velocity and 1.5 marks for finding out mean free path. That will be the split of the uh, marks. And now to solve the problem, just to list out what are the things given. Fermi energy 5.5 electron volt, it should be in joules. Okay, this is the mandatory thing. And to convert electron volt into joules, we have to multiply 1.602 into 10 power minus 19 to the electron volt. Okay, if you want to convert the joules into electron volt, you have to divide the energy value by 1.602 into 10 power minus 19. And always remember, all the expression for energy in SI unit will be in joules. Okay, even though electron volt is more obviously spoken in the classroom, but electron volt is not the exact SI unit of energy. Okay, you have to remember it. And the next thing they have given is the relaxation time tau. I have made a mistake here. It is 3.84. Okay, instead of that, I have substituted 3.97. Okay, it should be 3.83. And these problems are picked by previous year question papers. Therefore, these are very important. Don't neglect these questions. Okay, the first thing, let us answer the first thing. We have to find out the Fermi velocity or energy of velocity of the conduction electrons. I hope you remember this formula. E is equal to half mv square. This is the biggest achievement from the high school. E is equal to half mv square, right? Here, from this relation itself, we can extract expression for Vf. It is simply square root of 2Ef divided by m. Okay, this is a trivial equation. E is equal to half mv square. You know this from your beginning days of science studying, right? Now, in this, they have given EF. Okay, substitute EF 5.5 into 1.602 10 power minus 19 and divide it by m. That is the mass of the electron, 9.11 into 10 power minus 31. Okay, and you should get this answer 1.39 into 10 power minus 6 meter per second. Okay, you just try it on your own so that you will find, I mean, so that you will be confident enough to answer this question in the examination. Okay, now the second part, you have to find out the mean free path. I will call it as lambda. Mean free path is the distance between two successive collisions. And again, to find out lambda using Vf, we have to use the obvious equation. V is equal to F lambda or the modification of that. V is equal to F lambda, or you can use V is equal to distance divided by time, right? V is equal to distance by time. Velocity is nothing but the distance traveled, that is the distance traveled between two successive collision, mean free path lambda divided by the time taken. What is the time taken? Time interval between two successive collision is the relaxation time tau. Using this obvious formula for velocity, you can find out lambda. You already know Vf, right? It is 1.39 into 10 power 6 meter per second. It is almost 10 lakh kilometer per second. Okay, sorry, how much is that? 10 power 6 means 100,000, 10,000. Okay, it is almost 1 lakh meter per second. Okay, electron, sorry, how much is that? 1 lakh, 10 lakh meter per second. That means 10 kilometer per second. Okay, that is the speed of conduction electrons inside the silver. And tau is given, right? Relaxation tau is given 3.83 into 10 power minus 14. Just observe here, I have written 3.97. That is a wrong thing. Okay, it is 3.83 into 10 power minus 14, and by multiplying that, you will get the mean free path. Don't forget, mean free path is measured in meters. If you don't write the unit, you will lose 1 mark. That is a very disappropriate way of valuation, but somehow if you don't write the unit, you will get 1 mark less. Therefore, lambda is 5.518 into 10 power minus 8 meters. Just try these problems on your own. Okay, let me go to the problem number 2. I hope problem number 1 is not that difficult. Two formulas, 3 marks or 4 marks to get. Okay, in the problem 2, again let me read out the problem. Calculate the probabilities of an electron occupying the energy level 0.02 electron volt above the Fermi level. This is a very important problem. Okay, and then in an energy level 0.02 electron volt below the Fermi level. Okay, let me read once again. You have to find out the probability of electron occupation in a energy level 0.02 electron volt above the Fermi level, and then in an energy level 0.02 electron volt below the Fermi level. Okay, and that you have to do at 200 Kelvin. Okay, what is the formula to find out the probability? That is Fermi factor formula, right? F of E is equal to 1 over E minus EF by KT plus 1. This is the formula that you have to adopt. According to this formula, let us find out what are the things given. Here, temperature T is given. It is 200 Kelvin. And what they are asking, you have to find out the probability of finding electron 0.02 electron volt above Fermi level. Suppose if you have a energy level over here, if this is the Fermi level, then you have to find out the probability of finding the electron in the energy level. What is the difference between the Fermi level and the energy level? It is 0.02 electron volt, right? Therefore, what they have given is delta E. Delta E is the energy interval between these two energy levels. Okay, that is E minus EF is given 0.02 electron volt. Okay, don't confuse it with E. It is not E. 0.02 is the gap between Fermi level and the required energy level. Just read out this carefully. In an energy level 0.02 above Fermi level. Above Fermi level means difference between Fermi level and the energy level that you have to find out. E minus EF is 0.02 electron volt. Okay, substitute E minus EF and T. I hope you know what is K. K is the Boltzmann constant, 1.38 into 10 power minus 23. Temperature is 200 Kelvin, and energy gap delta E is 0.02 electron volt. Therefore, convert it into joules. Multiply 1.6 into 10 power minus 19. Once you calculate that, and you should understand, you get positive power for E. E power plus 1.1594 plus 1. Okay, and this is the value for Fermi factor. This is the probability 0.24. Okay, this is the electron occupancy probability. And you can understand 0.24 Fe means there is a 24% chance of finding the electron above the Fermi level. Okay, and let us move forward. And here also you have to find probability of occupancy in the energy level 0.02 electron volt below the Fermi level. Now, if this is the Fermi level, here also you have to find out the probability of occupation. Okay, if the electron is somewhere here, you have to find out the probability. Again, the gap is given. Delta E is given. E minus EF is directly given. But you should understand E should be lesser than EF, right? Since energy level under consideration is below the Fermi level, therefore E minus EF will become negative. It is minus 0.02 electron volt. Okay, this is very crucial thing. Students quite often make this mistake also. They don't write minus. You have to put minus 0.02 electron volt, and that should be converted into joules divided by same thing. Okay, now you should get minus 1.195. 1.1594. In the previous case, you have obtained plus 1.1594 for E, but here you will get a negative sign minus 1.1594. Okay, if you solve this, you will get F of E as 0.76. Therefore, just make this sure you write this statement. F of E is equal to 0.76 for an electron. Okay, to occupy the energy level 0.02 electron volt below Fermi level. Okay, And this is how you have to answer. This is a very important question. Usually this question will be there in the examination. Okay, model question papers also shared with you guys, and in that you might have seen the same problem was discussed. Okay, now let me go forward. Now there is a problem on finding out Fermi energy levelet. You have the Fermi energy levelet is given. Okay, and I think this problem is not there according to your syllabus. Okay, forget about problem 3. This problem is not required. Okay, forget about it. This part is removed from your syllabus. Okay, this is not required. Let us go to problem number 4. Okay, here you have to find out Fermi factor for an electron. Okay, with energy level 0.02 electron volt above the Fermi level, and there are two cases. Okay, one for T is equal to 200 Kelvin, other for T is equal to 400 Kelvin. This question is again taken from a question paper, and we have already done this case, right? 200 Kelvin case is already discussed. Let us go for 400 Kelvin case. Okay, again you have to understand f of E, you have to find out for the energy level 0.02 electron volt above Fermi level. That means E is greater than Fermi level. Therefore, it is positive. Just substitute all the things. Okay, I will do only the part 2. Okay, at 400 Kelvin, because part 1 is already discussed. For 400 Kelvin, the problem will look like this. Okay, again you have to substitute 1 over. Again, don't miss out this formula. Okay, you have to write this formula. This again it will give 1 mark. Otherwise, they will deduct the mark. Okay, I hope you remember. For solving problem, there are step-by-step mark provision is there. For the formula, you will get 1 mark. For the substitution, you will get the 2 mark. For the calculation, you will get the 3 mark. For result with correct result with, I mean, what is that? Dimension will give you 1 more mark. That is the split of marks. Therefore, don't forget to write this formula. In this formula, in the place of E minus EF, substitute the value. Okay, 2.2 into 1 minus 1.6 10 power minus 19. In the place of T, you should substitute 400. Okay, and finally you will get f of E as 0.36. Okay, this is the required answer. F of E is equal to 0.36 at 400 Kelvin. Very simple problem, but very important. Okay, let us go to the problem number 5. In the problem, calculate EF for the metal at 0 Kelvin. Okay, forget about it. Again, this problem is excluded from the syllabus. Don't bother about this. We don't require it. Okay, let us go to the next problem. The next problem is like this. The Fermi level in silver is 5.5 electron volt. What are the energies for which the probability of occupancy at 300 Kelvin are 0.99, 0.01, 0.5? Okay. Again, here we have to make use of same formula, but we are not finding out f of E. They have given f of E. Probability of occupancy they have given. It is for first case 0.99, second case 0.01, third case 0.5. Okay, these are the 3 different values of f of E. You have to calculate E. Okay, and that is exactly you have to find out E for f of E 0.99, and then for 0.01, and then for 0.5. I will show only one problem. Okay, only one solution. You will find 2 energies corresponding to 2 different f of E's, that is 0.01 and 0.5. Okay, let me summarize what are the things given. Fermi level itself is given. Fermi level itself is 5.5 electron volt. You should convert it into joules, and then they have given the temperature 300 Kelvin. You have to find out energies. Okay, for 3 different values of f of E. For f of E 0.099 and the remaining 2. Okay, I will show only E1. You can substitute f of E as 0.01 and find out f2, sorry, E2, and you can substitute 0.5 and you can find out f of E for E3 for 0.5. Okay, which formula you are going to use? this is the only formula. Okay, this is the only formula. F of E is equal to 1 divided by e power E minus EF by KT. Here they have given EF, they have given T, and K is obvious thing, and F of E is also given. F of E is 0.99 for the first case. What you have to find out is the E. Okay, E is under question. You have to find out E. To do that, we have to modify this formula because E is in the power of exponential. Okay, you have to bring this E down. It should not be in the power of exponential. How can you bring exponential power down? You have to take log. Okay, you have to take log on both sides, and then exponential and log will cancel, and power of exponential will be a multiplier. Okay, let me show how it has been done. First, consider this formula and then cross multiply the denominator, and you will get F of E into e power E minus EF by KT plus 1. Okay, a little bit of algebra is required here, and that will be equal to 1, right? I'm cross multiplying this thing, and then multiply F of E with e power this thing plus 1. F of E into e power E minus EF by KT is the first term, and F of E into 1, F of E into 1 will be F of E, and this should be equal to 1. Now take this F of E to the right hand side. You will get 1 minus F of E is equal to F of E into e power E minus EF by KT. Now take log on both sides. Since it is exponential, you have to take natural log. Okay, therefore equation will become ln of F of E plus, you can see I'm using this log of mn will be equal to log m plus log n. I will consider this as m, F of E as m, and e power E minus EF by KT as n. Okay, log of m into n will be log m plus log n. Okay, very simple thing. I'm just elaborating it. Okay, ln of F of E plus, what is ln of exponential power something? Simply the power of exponential. Okay, ln and exponential will cancel each other, and the power will come to the multiplier. Okay, E minus EF by KT. If you don't understand this step, please ask me. This is a simple mathematics of logarithm. Now ln F of E plus E minus EF by KT will be equal to ln of 1 minus F of E. Okay, this thing you will get. Now again we require E, therefore I will make some more modification. E minus EF by KT I will keep here as it is. I will take ln of F of E to the right hand side. Then you will find ln of 1 minus F of E minus ln F of E, and cross multiply KT now. Then it will become E minus EF. I have skipped a step. E minus EF is equal to KT into ln 1 minus F of E minus F of E. Okay, take EF to the right hand side, then you will get this formula. The energy E is equal to EF plus KT into ln 1 minus Fe minus ln Fe. Okay, this is the required formula. Here first substitute F of E as 0.99. Okay, substitute F of E as 0.99, substitute K, substitute T as 300 Kelvin, which is given, and EF 5.5 electron volt into 1.6 into 10 power minus 19 joule. Okay, then you will get E, the energy level corresponding to F of E 0.99. Then for the second case, substitute F of E as 0.01 and find out the second energy level, and then substitute F of E as 0.5 and find out E. Okay, using this equation one can obtain E1, E2 and E3. Okay, I have not solved this problem completely. I have just given the required formula. You substitute F of E's which are given, and then you find out E. Okay, this is a very important problem. Again, I am saying all these problems are repeated many times in the question paper. Okay, therefore don't neglect them. And let me show the last problem of this chapter. You have to find out the temperature at which there is a 1% probability. You have to find out the temperature. Find the temperature at which 1% probability that state with energy 5.5 electron volt above Fermi level is occupied. Okay, this is the question. Read out the question once more. They are asking you to find out the temperature, right? You have to find out the temperature. F of E is given, that is 1%. So just check out here. F of E is 1%. What is the meaning of 1%? 1 divided by century. Cent means 100, right? 1 per cent, 100. F of E is given 0.01. Okay. And above Fermi energy, that is said, right? Above Fermi energy. Above Fermi energy means they have not given energy E. Instead, they have given E minus EF. You just see a state with an energy 0.05 electron volt above Fermi energy means they have given directly delta E. E minus EF is given, convert it into joules. Okay, 0.5 electron volt, that is equal to 0.5 into 1.6 10 power minus 19 joules. You know E minus EF, you know F of E. Now you have to find out T. Okay, which formula? Same thing. F of E is equal to 1 over E minus EF by KT plus 1. Okay, now make use of this formula which we have used in the previous problem. E is equal to EF plus KT ln 1 minus F of E minus F of E. Here E is not known, right? E is not known, but we know E minus EF, right? We directly can substitute E minus EF here itself. I think you can understand here. E minus EF is already known. Okay. Therefore, E minus EF is equal to KT into ln 1 minus F of E minus ln F of E. This is the required formula. Okay. Make use of this formula and try to find out the temperature. I have given the answer directly. T is equal to 1261 Kelvin. 1261 Kelvin, very high temperature, almost equal to temperature of black spot of sun, 1261 Kelvin. This much of temperature is required to find 0.01% of electrons above Fermi level. Okay, this will finish up the chapter. I have given 7 problems, out of which only 5 are in your syllabus. Practice all the 5 problems. And if you are not able to solve on your own, please ask me. I will explain how to solve them. Okay, with your calculators it is very easy to solve them. Just you have to understand what is the logic behind the problem. Okay, now this finishes the module 5. Okay, this finishes the module 5. I will start the lasers, which is very much important from the point of view of examination. Second internals, you have lasers and optic fibers as the syllabus. Okay, therefore for now forget about module 4. Okay, just solve this problem and forget it. Try to learn the derivation part of module 3, that is from lasers and optical fiber, and I will tell what are the important questions from laser. I think optical fiber will be done by HOD. I think he has already started. I will start lasers from tomorrow. Okay, I don't want to hurry up. No, not tomorrow, from Monday I will start lasers. Okay, I will explain what are the important things. There are 3 main questions from laser part. Okay, that there will be there, I mean that they will be there in the examination. Okay, for today I will stop the class. Okay, thank you very much for joining, and if you have any difficulty, please ask me. I can repeat the class as many times as possible, and please save the notes. Okay, save the notes and keep it with you. Thank you very much for participating. Bye.